Hi and welcome to TM Electronics and more. My name is Tony and yes, we have yet another repair. This time we have 1.5 meters of a repair. Look at this. I really hope that video length will not be linearly correlated with that. Let's first have a look at what we have here. Couldn't find any data on this, but as you can see, this is some sort of portable speaker, audio amplifier, controls in the middle, and down there battery pack, charger and wireless mic. Amplifier and mic are made by well-known brand SHURE, made in Canada, but the product itself is a MES brand, MEC, so just one S, it's not a mess. PO-2301 portable amplifier. I think that is a local Slovenian brand, but I'm not sure if they still exist. I like how the product is built. It really looks like quite nicely engineered and have some nice features. It can handle two mics, one wireless, one wired via this 6.35mm jack. Then it looks like we have another input or output named CAS. It's probably input for some sort of cassette player, if anyone still remember those. This input jack down there is labeled as load, but that's just a charger / power supply input and an on-off switch. And that's it, and that's all you need. Even the charger is interesting. Beside the main power output, it also includes the 9-volt battery charger for the mic. Okay, let me fix my camera on the tripod and I will be back soon. Now the problem is, let me just show you. It's on, it's a little light in there, and I will increase volume a little bit. Here we go. As you can hear, there is a lot of high-pitched noise. At this point, please excuse me for my bad terminology, but I'm not an audio expert, so you will probably hear more of weird stuff from my mouth from now on. This is actually a common problem in all audio world, but good amplifiers are able to detect that amplifying noise and actively suppressing it. The other option is that you manually lower the amplification of troubling frequencies on a mixing table. The first thing you do when you are installing your equipment in a new place. This echo is like some sort of system echo and it needs to be cancelled. I'm not sure what we are dealing with, but the guy said that it was okay till now, or I don't know, a few days ago, and now it suddenly started doing this annoying noise. In the past he said that you had to have a mic right in the front of the speaker to make that happen. So let's open this up, let's open the amplifier up and see what's inside and what we're dealing with. I was just moving things around and that wire fell off, but we will just solder that back. A lot of pots in there. Oh no, the variable inductors and the pots here. So analog stuff. One pot has access from the outside, so it's squelch. I don't know. I'm not an audio expert. We have everything you need to engage the Google. Well, I think I was wrong at first. We have a power. That's clearly a power because it's on the DC jack and just one wire. What this is, it's just a RS receiver for the mic and a preamplifier for the other amplifier, for power amplifier that it's down on the controls. Oh yeah, and by the way, these pot that is accessible through the case. Squelch, that's just for adjusting the balance about the amount of noise and amount of usable signal from the mic. Probably we will fix this by adjusting some of these variable inductors or variable resistors, but I'm still not sure which one does what. So I will have to find something. I don't want to do the reverse engineering of this board. And all of that variable inductors are for the RF receiver. This lower one is the volume control. This one is squelch control. So all we have left is this pot, but as long as I don't know what this one is doing, I will not turn it anywhere. The noise is going from about let's say 1.5 kilo to around 4 to 5 kilohertz, and depends on the location of the microphone. I opened up the lower power amplifier. It's convoluted. Every millimeter is populated, so not easy to repair. It's some budge wires here, but it doesn't matter. I still think that the problem is not here, but let's not rule that out for now. The signal comes in here on the directly on the pot on the volume control for the wireless microphone, and snakes the way down to the power amplifier that is down here. Not sure what to do next. I don't find any data on this, and I really don't want to reverse engineer everything. No, it's not the power amplifier. It must be either preamplifier or maybe even the mic. In theory, we could, let's say, blank out everything from 1 to 5 kilo, but you don't want this. Even though the speech, that's the main purpose of these speakers, the speech is lower than that, but the higher frequencies add a little bit of, let's say, sound color to it. So we can just filter out everything from 1 to 5 kilos. Well, this mic saw better days. I don't know what they're doing with it. Let's open this up and see what's inside. The filter foam, it's old and crusty, it fell off. Let's take the battery out first. And we have a gain control, but that's gain over the whole frequency range, and that doesn't help us. I figured out. I have to take the ring out to take out all the PCBs. This is quite complicated system. First stage is of course microphone with a preamplifier that's probably in there. We won't touch that. I really doubt that the problem is in there. And then we have this sandwich PCBs. So this board seems to be RF stuff, and the other board, it's audio preamplifier. I found the service manual for this, and for any kind of repair you have to desolder all the boards apart. I'm not willing to do this yet. So then we have RF transmission to the RF receiver, and here we have a bunch of filters that are filtering out the audio signal. And that signal, of course, is again preamplified and sent to the power amplifier down there. This power amplifier has no pots or variable inductors for tuning purposes. So now what I think that happens, over the years, one of the components or few of them drift somewhere, and one of the filters drifted off from the factory settings. I don't have any service manual for this amplifier or the power amplifier down there, so it's kind of hard to find where all the filters are or how to tweak them. One of the solutions would be like a low pass filter right before it goes off to the power amplifier. Not the best solution. The problem could be anywhere. It could be, of course, on the preamplifier. It could be on audio PCB in the microphone or the RF PCB on the microphone, where all the mixers are. Well, the schematic of this is not so simple. Then we have RF receiver. We have to extract the audio signal from the carrier. That's done with these filters. And again, we don't know on which stage we have like a low pass filter. So how to measure these things? The easiest way, I think, is that we assemble the microphone back and then measure from the source to the end the level of that annoying noise. Even though that these speakers actually worked, there seems to be more than just one problem. I don't know, it was overheated or what happened to this. Let's fix this a little bit. Some elastic, some silicone on the bottom to hold the wires in. This heatsink, it's doing almost nothing. It has really bad connection to the pair of power transistors. The second one actually is cooled down by this nut in the middle. Okay, maybe they don't heat too much. I see a trace damage here, but I'm not sure if that was before or from my teardown. It could be. I removed the heatsink and they didn't get obviously the right angled switch, so they just took some wire from some components and solder vertically and then put a switch horizontally. Well, it's okay. That's flapping in there. Another switch, right angled in quote marks. The power LED, well, the LED that indicates the power. For our mic that comes in here, USN741, so this is a standard amplifier, and another one here for another input probably. Then it's TDA2301A. From top of my head, I think that's also on audio amplifier. And another one down here, MES71D05A, so 5-volt regulator, 100 milliamps. I think that it still makes a connection, but we will fix that with a wire. TDA 2003 power amplifier. Well, we can rule the first amplifying stage out by connecting our microphone to the second stage. I will do that, and I will try it, and if it is the same, we can rule out the first part of the electronics we have. But the TDA amplifiers gets really hot really fast. I'm not an audio guy, but I think that's not normal. Let's give the heatsink back so we will not damage anything. Okay, after about 2 hours of playing around, the problem is not in the power amplifier. Let me tell you what I did. I bring the other input to the mic 1 input on the power amplifier, and the annoying noise came up in the really high volume settings. So in the low end settings there is nothing there. So I think that's a proof that power amplifier does not do that by himself. I also attached another microphone to the channel 2 of the power amplifier, and no, it was working just fine. I tried quite few things in the last 2 hours. SM58, it's I think the most popular microphone on the world. I'm sorry I started without you. I already opened the battery cover. Let's take the battery out. Yes, it's another one. The first one is charging up right now. I had to remove this inner ring, so to get the PCB out. I also remove this cover and the buttons. So if you take this out, well, I have to admit, I opened this up. There are 6 notches that has to be open to the outside, and you can bring the PCB out, but there is nothing interesting there. It's just quite impressive rubber work inside to suppress all the noises, all the vibrations from the hands, or the unnecessary or unwanted noise. But on the PCB inside there is almost nothing, just a few filters, mostly all the passive stuff. What I also did is that I remove this capsule type of microphone, and I take another microphone and attach to this the other way on the ground and the audio, and the annoying noise was immediately there. So that rules out our PCB problem. So what we have left? RF PCB, there's nothing wrong with that. I tried quite a long range test. As you can see here on this board, we have on-off switch for all the board and on-off switch for the mic only. Quite a lot of tantalums. This is NE571D. That's its audio amplifier, nothing special about it. But this is the interesting part. This is NE571D. That little body has a capability of let's say dynamically amplifying or suppressing the frequencies or frequency range or whatever you want based on the surrounding elements. It's doing quite an impressive job. Even when no microphone is attached, we can hear background noise on the speakers. And remember, without the microphone, when I tapped on the PCB gently, the noise goes away. And if I constantly tapped on the PCB and attach microphone, even the annoying noise goes away. So that's doing something. I really didn't want to dive so deep into the technology of the microphone or the amplifier or the power amplifier or anything. It should be like a 5 minute repair, but well, here we are. Let's look at this 571. As I said, it's really interesting. It has its two-channel job, and either channel may be used as a dynamic range compressor or expander. So that thing is doing dynamic frequency range adjusting based on the detected average values of the signal. It's also temperature compensated gain cell and op amp inside also. So yeah, that explains it, because when I start talking, this annoying squealing sound goes away because it detects my voice, and my voice is priority at that time, and it suppresses all other sounds. The more interesting would be how to tweak this thing to do what we want. So we are interested more in the compressor side of it, not the expander. Test circuit. I will have to read a lot of this to understand what's going on here. No, that's not that easy. That's not that simple. No, that's really not simple. Oh, should I bother with this? There still is another solution, that is just a RC filter, not the solution I want. Okay, that's it. I give up. I test literally everything. I reverse engineer the microphone PCBs, I reverse engineer the amplifier or the mic receiver PCB, I reverse engineer the power amplifier PCB. I test everything I could. I didn't find anything. I even feed in with my function generator the signals, and the response is as expected. Nothing is peaking, nothing stands out of the amplification chart. So all I can do now is to adjust the frequency response so that my customer will notice some improvement. So what I will do, I already insert a little RC filter in there in the microphone. It's about 6 dB on 1 kilohertz, and about I think it goes up to 20 dB on the 20 kilohertz, so it's like a low pass filter. I will do the same on the receiver board, and if needed I will do the same on the power amplifier board. So we will get worse system overall response, but the customer will see improvement. Let's just do it and put everything back. I think that there's nothing wrong with it. The topology of this board is really very similar to the one that we have in the mic. Instead of membrane microphone, we have receiver, and then goes to the amplifier, this MC33179D, the same as in the mic. And then we have again NE571D, that's the dynamic range suppressor or expander, so that's the same. This is just the pot to adjust the gain of this audio amplifier, and that's the same in the microphone. So we will do just the same. Right before the signal goes into the audio amplifier, we will insert a little RC filter in there. I will do just a little different approach this time. I spotted a little, like say, mid-stage filter. I will add some capacitance, maybe 2247 nanofarads across this 100 kilo resistor. Test what it sounds like now. That's enough, and later I will do the same test. I will not move anything. 47 nanofarads, let's try it. I will turn the power amplifier on. I will turn on the mic and then the orange LED will come bright. That's it. Now I'm only worried about the frequency response of the speech. So okay, let's call this a quit. I don't know how should we call this. Is it a repair or is it just a improvement? Let's say it's like an improvement. And no more squealing, high pitch, annoying noise, even though I'm a meter away from the speakers. The sound, of course, is terrible, but what do you expect from these treble-like speakers? By the way, I really hate repairs when you're repairing stuff that already works. That's annoying. That's really annoying. So, have a nice day and see you next time. Bye.